So, in today's lesson, we are actually going to take a look at our periodic table. We have been checking out atoms. Okay, remember an atom is made up of our three subatomic particles, our proton, which is positive, our neutron, which is neutral, those are in the nucleus, and then our electrons, which are in the cloud outside, and those have the negative charge. We're now going to look at the periodic table and see, oh, this is set up based on our protons. Okay, our atomic number is going to help set this up. And we're going to take a look and see the different groups and why things are set up the way they are. So first things first, sorry that my table was a little wonky, but you are going to take one of your periodic tables from your bin. Okay, remember you're supposed to grab two, so one of them, and you're going to get a yellow coloring instrument, a red coloring instrument, and a blue coloring instrument. I would suggest colored pencils. They're just easier, maybe crayons. Markers kind of bleed through. But you are going to color the metals yellow, and the metals are this whole section. Pull up my pointer. This whole section right here. Okay, they're kind of white on my thing. Be careful in this area. We're going to talk about this area in just a second, but we're going to color pretty much everything through columns 1 through 12, okay? And then you're going to be careful not to color in this blue area. And the next slide is a little bit easier to see. Okay, you're also going to color the bottom two rows. Okay, so that's your metals. Next is your non-metals, okay? And that is on this right side here. So all of column 18, most of column 17, 3 of column 16, 2 of column 15, and 1 in column 14, okay? And then the last part is you're going to color the metalloids. The metalloids, and you may want to start there, okay, with your coloring. The metalloids are 7 elements that have both metal and non-metal characteristics. We're going to talk about that. So you want to color B, Si, Ge, As, Sb, Te, and At. And you want to color those blue, those 7. That is called your metalloid staircase. I want you also to draw in black pencil or crayon or pen that staircase line, okay? Like I said, so you can either pause here or you can look at the next slide, okay? Very similar. This one just doesn't have the labels of the elements, okay? Also note that you are going to color number 1, hydrogen, red, because he is not a metal. He is a non-metal. He just happens to be over there based on other characteristics and the fact that it has 1 electron in its outermost shell. We're going to talk about that in our next couple slides, what that means. But pretty much the reason he is on this side right here and not over here with his non-metal friends is because of that 1 electron in the outer shell. Okay, so take a moment and color. And again, I just highlighted that for you. Make sure you draw your line for your staircase. Okay, so on the yellow piece of paper, where it has metals, non-metals, metalloids, periods, and groups. Okay, remember you're supposed to get 2 yellow pieces of paper. You want this first one. We're going to talk about some of the properties. So our metals, okay, and you're going to write underneath this. Also, in the little box, color your color. So it's a color code. So metals, you were supposed to color blue, so color your box blue. Your metals are solid at room temperature except for one, which is mercury. That's usually what's found in thermometers. Okay, that's why if you break a thermometer in my class, you have to tell me, because mercury is very, very poisonous. And we don't want you getting sick because you know Miss B doesn't like paperwork. So all are solid except for mercury. They're really good conductors of electricity and heat. It's why we tell you not to stand outside with a metal stick, like golfing or certain types of umbrellas in a lightning storm. Okay. And think about heat. Think about if you left a metal spoon in a pot, what happens to the spoon? Or think about the pot itself as you are cooking your macaroni and cheese on it, right? It gets hot as it cooks. They're ductile, which means they're able to be made into a wire. So you take a piece of metal and you pull it, kind of think of like Play-Doh with in Play-Doh when you did the snake, okay, you were able to make it long and thin, same process. Malleable, malleable means I can take this metal, if it was in like a rock form or like a chunk, and I can hammer it down to make it a sheet. So I'm able to flatten it. I'm able to bend it. Malleable means I can bend it. Okay, so I'm able to shape it. Being malleable means you're able to be shaped. So metals are malleable. You are malleable. I'm shaping you into the next generation of future leaders. Okay. Lustrous. This is everybody's favorite. Metals are shiny. Okay. So think about for Moana. Okay. The giant crab would love a metal because it's shiny. Okay. Things like that. In a chemical reaction, this is really important, and we're going to talk about this in the next unit. In a chemical reaction, metals are going to lose their electrons, and they're going to become positively charged ions. It's called a cation. Okay, cat has a T in it. Positive sign looks like a T, so it's a positive charge. We'll talk more about that next unit. Okay. Most of our, if you look at your periodic table, it's mostly blue because most of our elements are metal. Okay. Our non-metals, okay, and on your sheet, you're going to color that red, okay, the box red, okay. Mostly gases, liquids, and solids, okay, mostly gases. There is one liquid, it is bromine. There is a couple solids, carbon, sulfur, okay, but mostly gases, okay. And if you look at the periodic table on my wall, you can tell because all of my solids are black, all of my liquids are blue, and all of my gases are red, okay. And then anything that is like white and just has a black outline, it means they're synthetically made. I made them in a laboratory, okay. They are poor conductors of heat and electricity. You want that. Think about oxygen. Oxygen's a non-metal. Pretty sure you don't want the air you're breathing to contain the ability to conduct electricity, because that would suck every time you took in a breath. They're not lustrous. It's hard for a gas to have shine if it's a gas, okay? Because we don't see gases normally. Our solid nonmetals, like our carbon, our silicon, our sulfur, they're very brittle, which means they break easily. And these are the guys that they're going to take on electrons. So my metals are going to give up electrons. They're really good at giving things away. Okay, they're very generous. Okay, my non-metals are going to be, they're going to be really good stealers. Okay, they're thieves. They want electrons. So we're going to talk about why that's important again over the next couple slides and into the next lesson. But just know that these are going to take on electrons. Okay, and they're going to form what's called an anion because they're negative. Okay, they're also likely to share though. So even though they're thieves, there's honor among thieves, and they're willing to share their electrons with their non-metal friends. Okay, and then finally, those on the staircase, that 6 or 7 elements on the staircase, they're called metalloids or semi-metals because they're going to have qualities of both metals and non-metals. Okay, so they're dull, so they're not shiny like metals, but they're not not shiny either. They're kind of just dull. They're brittle, like the nonmetals, so they're going to break apart easily. Okay. And they can conduct electricity, but you have to do it at a high temperature. Okay. So you have to really pump up that heat for it to conduct electricity.